Well, let's talk about today's lesson, beginning of chapter 5. Call this nth roots. So let's study this core concept we have here in front of us. When you have an expression, let's start off by looking at this first one here. That looks like this. What I want you to do is basically jump right over to this. Let's leave out that middle step. And notice that a fractional exponent can be written as a root. So notice that the numerator becomes the power of the expression, and the denominator of the fractional exponent becomes the root. Now, if you look farther down, you will see the next expression, which deals with negative exponents. Now, all a negative exponent does is this. It just makes a reciprocal, which then in turn can be written in radical form. And then there's a disclaimer at the end that states that that number cannot be zero because that would make the fraction impossible to understand. So let's try this out. How about part A? Let's evaluate each expression. So 16 to the 3 halves power. Well, what I'm going to do is I'm going to rewrite this in this form, and I'm going to follow my guidelines from above. That number is the power. The bottom number is the root. You don't really need to write that root, but you can if you want to. So I'm going to undo it. So in this case, the square root of 16 is 4. So this is 4 to the third power, which is 64. Or do that on your calculator. How about we move over to the next one? It's a negative exponent, isn't it? So what this means is this is actually 1 over 32 to the 3/5 power. So that becomes a reciprocal where the exponent just changes signs. Now this, let me continue it over here, can be rewritten as a radical. 32 is in here. Okay, the numerator is the exponent. The denominator is the root. So what we need to do is figure this out. What is the 5th root of 32? And that would be 2, right? Because 2 times 2 times 2 times 2 times 2 gives you 32. So this would be 2, and then we still have the third power here, which is 8. So this is 1/8. Move on to the next set of problems. Let's try doing these problems with a calculator instead. So now you have to understand, how does my calculator work? Well, let's go ahead and try these out. Let's go to part A. I have a calculator right here. Move it over a little bit. Okay, so I'm going to type 9 to the 1/5 power. 9. Now you should have some kind of an exponent key. I've got a caret button for me. And I'm going to type the 1/5 power. I have a fraction key, so I could do this, 1 fraction 5, and I get my answer. Okay? Or I could have done this, 9 raised to the 1/5, so I can use division, 1 divided by 5. You might even want to group that in parentheses, depending upon your calculator. So there's part A, rounding to the, what's it ask here? 2 decimal places. That would be 1.55. Okay, let's go to part B. If I can figure out my calculator, we wouldn't have a problem with this. All right, part B. 12 raised to the 3/8 power. I'm going to continue to use my fraction key. This would be 2.54. The 9's big enough to round that up. 2.54. And then part C. Now you got this 4th root of 7. So I got to search through my calculator. Right here is the button. So I believe what I'm going to do is I'm going to put a 4, activate that key, and now it's made it the 4th root of 7. And now I want to put parentheses around this. I probably need to back up here. Should have just started my expression off with parentheses. I think I can squeeze them in. There we go. So everybody work on getting that typed in your calculator correctly. And then now I need to raise that to the 3rd power. So now you can understand why having a good calculator is so important. 4.30. That 3 is not big enough. 4.30. So let's try these without a calculator, everybody. Okay, number 5. Start off, put that into radical form. All right, so that would be radical 4 is 5 is the exponent. The denominator is the root. Now, since it's a square root, you don't really need to write that number there. So the square root of 4 is 2, and this is still to the 5th power. You can use your calculator for that, but that'll be 32. On to number 6. Now, in number 6, that negative exponent makes a reciprocal. All right, let's go through this now. Here's the exponent. The denominator is your root. Once again, you don't have to write it if it's a square root. So it looks like this will simply be 1 over the square root of 9, which is 3 to the 1st power, which is just 1/3, right? So we don't even need that. So there's the answer. All right, let's head down here to number 7. Let's put this into radical form. The numerator is the exponent. The denominator is the root. Okay, we got to think, what's the 4th root of 81? If you need a calculator for that, bring up your calculator and find out what's the 4th root of 81. I'll show you. So I'm going to do 4, 4th root of 81. All right, it's 3. But this is still being raised to the 3rd power. So that's going to be 3 times 3 is 9 times 3 is 27. Number 8, easy problem. 1 to any power is 1. Now let's solve equations. We need to remember that we work backwards through the order of operations. Okay, everybody? So step number 1 is to do your addition or subtraction. Don't see anything. Step number 2 is do the multiplication or division. We see division. Step number 3, do you see an exponent? We do. So we need to undo that. All right, now, how do we undo this? Well, there's a couple ways of looking at this to explain this, but you should know by now that you can do whatever you want to both sides of an equation. So what I'm going to do is I'm going to raise this to the 1/5 power on both sides. Now, why does that work? Well, over here on the left-hand side, what we have is we have an exponent rule. Do you remember what you do when you have a power raised to a power? You multiply, don't you? So what that would be, I'll do it over here off to the side. That's 5 times 1/5. It's like 5 over 1 times 1 over 5. That's 1. So what I've got over here is just x to the first power. Okay? And then 32, I could write that as 32 to the first power, and that's the 5th root. It's really the 5th root of 32. So that's one way to look at this, and x is 2. I could have done the same problem by just doing a root. So let me back this up and show you what I mean. So if you get to this point, here's another option. If this is the 5th power, take a 5th root. Why does this work over here? Why does that work? Well, if we think of this as a fractional exponent, here's your exponent for the numerator and here's denominator. It's x to the first power. So that works to undo this exponent. There's a lot of ways you can explain these things. How about that problem? Okay. Can we do this? No, can't do that. That 3 is tied in the parentheses. Okay, we can't do that. If you saw addition or subtraction or multiplication or division outside, you can do that. So we have parentheses actually. We got an issue with that. So what we need to do is we need to look through this. We don't see addition or subtraction. We don't see multiplication or division, but we do, outside the parentheses, we do see an exponent. We need to undo this. Okay, what do you want to do? I'm going to do a 4th root. All right. So what we're going to get left over is these roots and the exponents cancel out. And then what do we do now? Addition or subtraction? Well, it's traditional to write the number first and then your root next. Because it's the 4th root, it's an even root, there's a possibility of 2 different types of answers. Now, if you want to, you could put those into your calculator as well to get an approximation. Depends on the directions. Okay, let's have, in this case, it does ask you to do it. Let's go ahead and try these out. Try 13 and 14. Okay, so in 13, you should have chosen to do your division first. And then you take care of your exponent, which you can undo by doing a cube root. Excuse me, so this will be x equals 2. Now, have you noticed for odd roots, you don't get a plus or minus? It doesn't work. that way, does it? All right, how would you tackle number 14? Well, this is multiplication, so what I would do is I would multiply by reciprocal, which is just 2, right? So that cancels all this out. We have x to the fifth equals 1024. I think we need to do a fifth root or a 1/5 power. Well, we might need to turn to the calculator to see what the fifth root of 1024 is. So I'm going to activate my root button. 4 is the answer. Well, let's go a little bit farther. All right, we got a couple more. So here's some problems with parentheses. Remember, don't try to take anything out of the parentheses. I guess what we're going to need to do is remove that exponent right there. So we need to do a fourth root on both sides of our equation. So that will cancel out the roots. We're going to have x plus 5 equals the fourth root of 16. Now, do we know the fourth root of 16? We do, don't we? It's 2. So I guess I'm going to just rewrite this. It's going to be 2 different answers, isn't it, everybody? It's going to be 2 and -2, though, isn't it? That's because it's an even root. 2 multiplied by itself 4 times is 16, but so is -2. So for this, you actually have 2 different answers. There's one. So if you have even roots, you have to get used to that. We saw that with square roots. And there is the other. Okay, so how about everybody try number 16? Okay, number 16. Let's just kind of block that off so we don't look at that anymore. All right, how are you going to go about that one? I see a third power. Let's take a cubed root of both sides. So what will happen now is cube root and a cube cancel one another out. We've proven that before. And you have a cube root of -14. Now, an odd root is not like an even. You can have an odd root of a negative number. That is possible. Okay, you will not need imaginary numbers for this. I don't know what the cube root of -14 is, though. We're going to need a calculator for that. So let's just go ahead and add 2 to both sides. Now, these instructions state that we need to use a calculator. So I want to show everybody something. See, I've got that plus. I did not use a plus and minus. Odd roots do not require a plus and a minus. Go to your calculator. 2 plus the cubed root. Activate your root button. There we go. Of -14. Now remember, odd roots can be negative. This is going to be a possibility. We're around to the second decimal place, so it's going to be -0.41. We'll put these little squiggly lines, which means approximately. All right. Let's see what else we have in store for us. More practice problems.